Hello everyone, today we'll be covering DevOps CI/CD pipeline with Jenkins and Docker. So what we are going to do today is we'll be first discussing what DevOps is and what DevOps practices are and how they will help us to enable a logical pipeline which will be able to deploy a certain piece of software completely automated. Okay, and for this we will be using tools like Jenkins and Docker. So DevOps uses a set of sophisticated tools and tool chains in order to deploy software right from the time when we conceive them and keep them in our version control systems to the time when we deploy it in a production server. So the entire series of steps is named as a pipeline, and we use some sophisticated tool in order to get this thing deployed in the production. So before moving on, let's first discuss what DevOps is, and then we go on to discuss what CI/CD is and understand the concept of a pipeline, and then we move on to use our tools like Jenkins and Docker in order to deploy this pipeline. So first of all, before we begin with our agenda for today, let's understand what DevOps exactly means. So if you might be wondering that DevOps is a set of practices or DevOps is a new way to do things, actually none of these are exactly the words or phrases which make you aware of DevOps. DevOps is in fact an enterprise software development phrase which means how agile relationships between development and IT operations can be developed, and the goal of DevOps is to deploy things like you can deploy things automatically, and you can improve the relationship between the operations and the development team by advocating better communication and collaboration between these two business units, right? So what exactly DevOps does is to bridge the gap between the developers and the IT operations team or the system admin team, and it allows you to automate the processes by which they work. Like say the developer will just write code and then commit it into a version control system, and then DevOps team takes up from there and deploys it into a test server, automatically run the test cases, and based on the output of the test cases it can then deploy it further in the staging server where the client can view the code, and finally it goes to production. Now the main thing about DevOps is it allows you to automate this entire process or this entire flow right from the time the developer commits his or her code to the time when the code is ready or the product is ready to be deployed in a production server. Okay, so in effect, DevOps is not actually a new venue of IT, or it is not something new in IT. We have been already doing it, but it is a set of principles or a work culture using which we can automate processes and streamline processes so that teams can collaborate and do things in a better fashion, so that problems can be handled properly, and it is a culture that supports a willingness to work together and share knowledge. So DevOps in fact is just a culture or a practice. Now in order to put this practice into real operations, what you have to do is you have to use some tools. Like if I say DevOps is automating everything, so you cannot just automate things out in the thin air. So what you have to do is you have to put this practice into a solid base. Like you have to use certain tools or tool chains as we call them in DevOps, and using these tools we automate the entire string of operations so that the DevOps practices can be automated and the entire software development life cycle works flawlessly and seamlessly. So that is what DevOps actually does. In short, it follows the agile lifecycle process okay. And using the agile software development lifecycle process, what we do, we use certain tool chains and automate the process, and we deliver it faster and without errors, and we deliver the product which is seamless, like it can be integrated into other products, and it can be error free, so to say, because most of the things are not done by humans, it is automated by us, and in that effect it becomes error free. So the agenda is, first of all, we'll discuss how we can build a CI/CD pipeline. I'll explain CI/CD, what it means in the slides to come, and what a pipeline means. And once we are done with that, we will understand the role of a tool called Jenkins, which helps us to automate the pipeline, which we will discuss in point number 1. And then we move on to understand another tool called Docker and how it will help us in the deployment. And finally, we'll do a hands-on lab to demonstrate the entire pipeline automation. Discusses the CI/CD pipeline concept. So let me now open up the acronym CI/CD, what it means. CI stands for continuous integration, and CD stands for continuous delivery and continuous deployment. So what do these terms exactly mean? Number one, let's understand what CI means in DevOps. CI stands for continuous integration, as I said. Now, what continuous integration is, like say, you just imagine a software development life cycle, how it works. Just look at this diagram of this pipeline. Okay, this pipeline is a logical demonstration of how a particular software will move along various phases or stages in its life cycle before it is delivered to the customer or before it is live. Okay, so just imagine you're building a game which is going to be played on Android devices, or just imagine you're going to build a website which is going to be deployed on live web servers. All right, so any of these examples if you take, so your product is a website or a web app, right? So how is that app going to be developed in a software company? Number one, you will have a set of developers who are responsible for writing the code which will further go on and build a web app or a website. Okay, so now this code, when once the team of developers commit it into a version control system like Git or SVN, it goes through this phase. So that is the first phase of the pipeline, where developers put in their code, and the code goes to the version control system having a proper version tag. Now say the code is a Java code or an Android code, the code would need compiling before it can be executed. So then it goes through a build phase where you compile the code, you get all the various features of that code from various branches of the repository, merge them, and then finally you use some compiler to compile it, and that is called the build phase. Once the build phase is over, then you move on to the testing phase. So in the testing phase we have various kinds of testing. One of them is the unit test, where you test the entire piece of software for its sanity, as well as you do a feature test in order to understand how it works. And then once the test is completed, you move on to the deploy phase, where you deploy it into a staging or a test server, where you are going to view the code, or you are going to view the particular app in a simulator. So in the deploy phase, what happens once the code is able to be deployed successfully, you can run another set of sanity tests, and finally if everything is acceptable, then you deploy it to production. And meanwhile, in every step, if there is some error, say there is a build error, then you can shoot a mail back to the development team so that they can fix the error and then push it into the version control system, and it goes back into the pipeline once again. If there is any error reported during testing, similarly the feedback goes back to the dev team and they fix it, and then it moves on. So this is how in every phase it moves on throughout the life cycle, unless we get a code or a product which can be deployed in the production server, and there we can measure and validate that code. So this is the entire pipeline. So pipeline is a logical step, a series of steps which define how a software development life cycle occurs. So that is all about the pipeline. And what is then the CI? Okay, since there are various developers, say just take an example of a team which has 5 developers, and they are building this particular website which is a shopping site. So the shopping site can have various avenues, like one of them is the landing page where you show all the products. There can be another page which shows the user details and the past orders and things like that. There could be another page which is the shopping cart, which will show whatever products the person has added to the cart. There could be another page which is the checkout page, where the person will pay and then make the purchase. So there are various avenues in a particular software. These can be called as features of the software. Okay, so when you have multiple features, then you have to combine those features and merge them into a single version control system, where you merge the various feature branches of the code and make a single pool of code which can be now comprising all the features from various branches committed by the developers, and then you can build it as a product and move on to testing. Now when you merge the code and then you build the code to get a single unit of the software, that phase is called integration. Integration means putting together, right? So we are putting together code from various of the contributing developers, and then we are merging them and building it as a whole. So that phase is called the continuous integration phase. Why do we call it continuous? Because as I said, in DevOps we use various tools to automate the pipeline. Okay, in contrast to the traditional practices, what a traditional software company does: manually people write the code and manually put it somewhere, then they manually merge it and they manually build it using build commands, and then a tester manually tests it, and then it manually gets deployed in a server by a system admin, and then again there is a series of sanity tests manually done again by a QA, and then it manually is deployed to the production. Now what do you see here? In every phase there is a manually done thing, right? So that is how things are done in traditional way. In DevOps we transform this to do everything in an automatic manner. So as soon as a person commits the code from the repository, it completely automatically moves and merges itself with the other code which are present, which are committed at the same time, and then it triggers off a build reaction which will build or compile the code, and then it triggers the test, then it triggers the deploy, auto test, and so on. So the entire thing is triggered step by step automatically. So that is what we are going to achieve. We are going to create an automated pipeline. So why is it known as continuous integration? As I said, this version control and build phase are called the integration phase. Now since this is completely automated, it happens continuously. Like as soon as a person commits code in a version control system, it continually starts the merge process, and it continuously starts the build process. So that's why it's called a continuous integration. Nobody waits for anything. It's just a trigger which will then allow you to move on to the next step. So this is it. And then what is continuous delivery? As we move on to the other steps in the pipeline, then we finally deliver the product, and the product delivery or the versioning is continuous as well, because as soon as the test passes and the new features evolve as functional, then you can have it used in the final area as the product, right? So this entire process is continuous. It is continuously integrated, built, tested, deployed, and delivered. So that's why it's called a CI/CD process, like continuous integration happens and continuous delivery happens in this pipeline. And pipeline is just an imaginary flow of processes. Okay, it just shows how the process will go on automatically. Now you might be wondering, how can I automate the entire software process? That is the power of DevOps. In the upcoming slides, I'll be showing you how you can yourself do it using certain to this CI/CD pipeline shown in a better detail. So first of all, let's discuss the entire flow once again. The developer writes code, pushes it to the code repo. Code repo is something like a version control system you might have used, like Git and SVN, and then it is pulled into a CI server, the continuous integration server, which we refer to Jenkins here, and then it is integrated over there, and it moves on through various series of tests and goes to the staging. And this part is called the deployment or delivery, and this part is called the integration part, where you merge the code and build the code. To the same series of steps, here we define the continuous delivery part. So what happens, say this is the Git repo. Okay, so in Git repo you have various code, and then you merge them and build them and push them into Jenkins, which takes care of the entire automation. And then once the code is built, it is deployed in a environment called Docker, and Docker builds an image with that code, and then once the image is built, it instantiates a container which will run that particular piece of code and replicate the entire production environment, and then the tests would run there, and once the tests succeed, then you have a completely built product which can be deployed on production. So this is the phase of the pipeline. When you do the hands-on, you would be having a better understanding of this thing. We will move on to understand what Jenkins is and how we can deploy the demonstrated code using Jenkins and automate the entire process. So what is our task at hand? Our task at hand is to automate this entire process. Which process? Right from the time the development team gives us the code and commits it to the time we get it into production. The series of steps is the pipeline, and our task is to automate the pipeline. Okay, so we'll visit this. Now first let's have a look on the questions. If anyone has questions up till this, you can all ask me on the chat. I'll be checking the questions sometime in this session and giving you a reply to that. So meanwhile I go on and move on to the Jenkins part. You can ask me questions on the chat window and I'll be replying it. Okay, so what Jenkins is, as I said, in order to make the entire software development life cycle on the DevOps mode or the automated mode, we would need automation tools. So Jenkins will provide us the various interfaces and tools in order to automate this entire process. So what happens, we have a Git repository where the development team will commit the code, and then Jenkins takes over from there. It is just a tool with a front end where you can define your entire job or the task. What is our job? That is to make the continuous integration and delivery process for that particular tool or that particular application. So from the Git, Jenkins pulls the code and then moves it to the commit phase, like where the code is committed from every branch and merged. And then Jenkins, what it does, it moves into the build phase where we compile the code. If it is Java code, we use tools like Maven in Jenkins and then compile that code to get our jar file or the ware file which we can deploy. And then we run a series of test cases. The test cases can also be run by plugins like JMeter, or we can use something like Maven as well to run the test case, and then the test case is overseen by this Jenkins again, and then it moves on to the staging server where it is deployed using Docker, and then after a series of QA and sanity tests, it moves on to the production. So now let's have a look at the questions if we have any. All right, so here I see that there is Tanay who asks, what is meant by CI and what exactly is integration? So yes, as I said, integration is the phase where you combine the code from various feature branches, okay, and make them into one single piece of code compilation, and then you can move on to build the code. Say if it is a Java based project, you can build it to get using the Java compiler in order to get a jar file or a war file. If it is an Android based project, you can use the Android SDK to build an APK file. So that phase where you collect code, merge them, and build artifact is called integration. What is CI or continuous integration? As I said, we automate the process of this integration. Every time a person commits, it automatically triggers off integration or and build. Okay, so this is called CI or continuous integration. And finally, there's another question where I think Vivek asks, what is continuous delivery and continuous deployment? Okay, so we have discussed what continuous integration is, and on the same lines, continuous delivery or continuous deployment is nothing but it's deploying the software on a production like environment continuously so that it can be tested. So that is done by using a deployment environment called Docker. So we can continuously deploy that particular product as soon as it is ready after build, and if it is found to be fine and tested, and if the test cases pass, we can continuously deliver it to the customer. So that is the continuous delivery. And what is the difference between continuous delivery and deployment? Delivery will not have the phase where you have to deploy that particular software in a customer's environment, but in case of deployment, you have to deploy it in a production environment. Let me give you an example. Like continuous delivery will be the case when you are building an app. When we build an app, what we do, we test it, and then we upload it to the Play Store, where the customer will download and use the app for himself or herself. But in case of deployment, it is like a website or a web app where you have to finally deploy it on some production server from where the customer will use. So in delivery, you just build the app and package it and provide it. The customer can use whenever he or she wants. But in deployment, you deploy it on some endpoint or a server. Okay. Next, let's move on to the. So here we have the continuous integration and continuous delivery series of steps. So now what we'll understand how the delivery phase is going to be taken care of. As we have discussed, we will use a tool called Jenkins to automate the entire thing, and Jenkins will use other plugins like Maven to build it, and it will use Git to pull the code, and it will use some other tools to make the testing possible like JMeter. And then finally, in order to deploy it, we will need an environment which will replicate the production environment. So that is called Docker. So Docker is just like a virtualization environment which we can create on the fly. It will just take a few seconds to create an entire server and deploy something in that. And that is how powerful Docker is. It is not exactly a virtual machine, but it can create images just like virtual machine, and then we can run it as a container which will completely replicate a particular platform or environment where we can deploy our artifacts or our jar files or APK files which we want to test. Okay, so why do we use Docker? It's lightning fast environment creation. It's very fast. As I said, you can run entire clusters in a few seconds. Then we have a storage registry for images where once you can build your image and store it forever, and you can use it anytime on any environment, and it can replicate itself there. and the deployment speed is crisp, and as a result we have a very low turnaround time. Like if you have any issues with your current environment, you can just dispose it and run an entirely new environment in a matter of few seconds. And finally, Docker is very reliable and resilient. It doesn't break very easily, and it will give you less trouble. So it's a way to replicate the entire production environment very fast and very reliably. Okay, now move on to a hands-on lab where we will automate this entire pipeline, and then this demonstration will simulate a completely automated pipeline using Jenkins. So the first task is to understand how to set up this pipeline in Jenkins, and then we will set up the environment where we have a Java EE based project which we have in GitHub, and we will pull that code using Jenkins completely automated fashion, and then we build the code and we generate a ware file, and we'll be using Maven in order to build the code. And then finally we will run the test cases and ensure that they pass, and once the test cases pass, then we will copy the ware file generated in this step number 2 and build a Docker image, and then we will deploy it. So that would be deployment automation. And finally we will have the Docker JBoss image ready, which we can run as a container on the target node and automate the deployment phase. So all the steps will happen in sequence and make the entire pipeline process automated. Those who have already gone through the Jenkins and the Docker classes, they would be conversant with how we use them, and those who have done the Git phase and the Maven phase of our course, they will be conversant with how to use those tools as well. So this session is going to use the knowledge of all your tools, and in order to set up the entire thing seamlessly. So we can also use our other tools like Ansible or Chef or Puppet to do the same thing, but here we have chosen Jenkins and Docker. But in DevOps you have a tool chain in place. You learn lots of tools like Ansible, Docker, Chef, Jenkins, and Puppet, and Maven, and test automation tools. So once you have the knowledge of all these tools, you can just choose anything which suits you for a particular demonstration or production deployment and use it for your purpose. So for this we are going to use just Jenkins and Docker and a bit of Maven to get our thing done. So now let's get to answer some more questions, and then we move on to do the real work, the hands-on deployment. So here let's see if there are any more questions. Yes, we have 2 more questions now. Here I can see Anita asks, like, why is Docker used for continuous development in DevOps? Well, the answer to this would be Docker is very fast and we can deploy the environment in a matter of seconds. So that's why we chose it, because if you will be manually deploying or using certain other tools to deploy it, it is going to take more time than Docker. So since this is continuous deployment, we will not have much time to deploy the environment and test it and report it. So that's why we use Docker. And finally there's another question which asks, what will happen if the test cases fail after the build, and will it deploy the app to the production? Yes, this is an interesting question. Like when we have test cases which are failing in the pipeline, then the build process stops there, because if test cases fail, that means the product is not ready to deploy in production. So there is no use to continue with the software development life cycle there. We automatically abort the development pipeline process, and then we send alerts with the log files which mention why the test case failed and on which step it failed, so that the development team can automatically be alerted by Jenkins, and they can take the corrective measures and fix the errors. So it will not deploy to production and send the mail back to the concerned development team so that they can fix it and then trigger off the development process once again. So what we are going to do is to demonstrate the entire pipeline. So first thing first, particular Oracle VirtualBox Manager. Here I have the deployer running. This is one of the systems where I have installed CentOS 7, and we are going to do everything over there. And here you can see I have logged on to that particular server. It is having an IP address of 192.168.0.104. This is that CentOS 7 deployer system where we are going to do our exercise. So you can check the version here of the operating system. It's 7.2 and I am using a 64-bit. Apart from that, I have installed Jenkins over here and run the Jenkins service. So those who have gone through the Jenkins session would know how to do it. And here I have Jenkins service running. We can check the status here. Systemctl status Jenkins service active and running. Similarly, I have installed Docker here. So if I check the Docker process also, I'll get an idea whether it's running or not. So I can see Docker is also running here successfully. So I have Jenkins running and Docker running. Now let's get back to fetch the code, and GitHub, I have kept this particular demonstration so you can view it from there and you can use the code for your purposes. Now all the code that is required for this demonstration is present here. So this is a production code, so you can use it in production as well. So here what do we have? This is the Java web code, which is actually the software given by the development team. So this is something called Java EE Wildfly Spring Boot sample. So they have a set of code present here, and they have a POM file. That means we'll use Maven to build this code. So once we build it, we will get a war file, and that war file will run on 8080 port in our browser, right? So these steps and this code will be provided by the development team. You don't have to worry about it. So once you get them, you can place it in your build pipeline and make your pipeline automated. I'll show you how. So first we have this Java web code given by the development team. Then we have the integration testing code, this folder. This has the test cases. This is given by the QA team. Similarly, it will be run using Maven. When we see a pom.xml file, that means we have a Maven based server, like the builds will be done with Maven. Next, there is a folder for images, which is nothing but the screenshots I have kept here, so not related to the building. Then we have the Docker, where we will have one file which is called Docker file, which will allow us to build the images. So let's have a look into that file. So here in this file you can see there are a set of code which we use to build this particular Docker file that will build a Docker image, where we place the war file which is compiled after building this Java web code, and then we put it into the pipeline for testing. So this is the source code. So we can go here and clone this into our Jenkins job. So how to build a Jenkins job, let me show you first. This is the Jenkins interface, 8080 port of that particular server 104. Okay, so when you first click here, you get a page where you have to log in. So those who have done the Jenkins session would know how to do this. So we put in the password here and we enter the Jenkins dashboard. Now what we have to do, we have to create a pipeline demo. So we do a automated pipeline, that's the job name. We create a freestyle project because we are going to define everything we need for creating this pipeline. And here creates a complete pipeline for Java SDLC software development lifecycle. Okay, so this is just the description. Here we discard the old builds, say we will keep just 2 builds and discard the rest because we do not want our server to get filled up. Next we go on to move and discuss the source code management. This is from where the source code will be pulled. Like here we discussed each and every step. First step, we will pull the version control, then we will build it, then we will test it and deploy it. So these are the various phases. So here we are doing those or defining those phases. First phase, pull the code from version control system. So where is the version control system? Here. As I said, from here I can pull the code by copying this URL, and then I paste the repository URL here, and then I put in my credentials, and then I move on to the next phase. Build triggers. Do I want to trigger the build remotely? I can do that. If I want to build it periodically using cron jobs, it will build periodically. Say you want to build your software every day 10 p.m. in the night, then you can choose this and put the time sequence over here. If you want to make it on demand basis, then you don't choose anything. Like now we will be just building it on demand basis, so we don't choose anything in build triggers. In build environment, you can define any environment variables if required. We will define it in our scripts in the build step. So we just move on to the build step and add execute shell, where we will put on the shell commands for the build step. Now here in this particular project, I already have a build steps.md file, which is a markdown file mentioning what are the build steps. So the first step is to build the archive file to get a ware file. So I copy the steps, put it here, then let me explain you what the step means. So here first what it does, in the build phase it gets the code from here already pulled, and then what it does, it uses Maven to install that particular package. Install phase, what it does, it installs the dependencies and compiles the particular application. Okay, so clean verify will compile and then start the testing. So once that step is done, the code will be built and tested. Okay, and you have that phase over. Then you can add another build step where what you do is you do a provisioning or the deployment. So here I copy this step and I paste it as the second step. The build and test it over is over. Now you use Docker to provision it. The final step would be to have the container running. So we remove everything which was already running, or if the container exists already, it will remove it, or and then it will run it as a new container. So let's not add a new step, let's append it to that same step, because it doesn't matter if you have 2 steps or 3 steps unless you get the entire pipeline thing done. So what we do, let's reiterate, we build it using these steps. We have done all these steps before, but we have never done it together as a pipeline. So here we are. First we use Maven to build it, then test it, and then we use Docker here to build the image using that particular ware file which we created in step number 1. Once the image is ready, we check if there is a container with the same image already running. If it is, then we remove it using this command, and finally we run a new container which will run on 8180 port and show us our website on this particular location. Okay, so once you are done with the steps, apply it and save it. Now you get a new build plan, and if you look at the workspace you won't find anything, it shows error. Okay, that means we don't have anything inside the workspace yet because we haven't built the step as yet. So once we build it, this will vanish and it will show us the current status. So we can click here and start the build process. So here you can see the build process has started. So what do we see here in this build process? It is doing the downloads, and it is then once everything is downloaded into our particular repository, we will get our result here. Okay, so this is how we can automate our build phase. So here we have another DevOps pipeline doing the same thing, so we can build this one and see what happens, because this one already has everything cached up, so that will be a bit quicker to do our testing. So if I do the build scheduled here, let me move on. Here what happens, you can see the build phase has started and the Maven compiler is compiling everything, and then the build is successful and the test phase has started. Now once the tests are done, the test will be successful as well. Yes, the tests have succeeded, and so we have moved on to Docker to build the Docker image. Once the Docker succeeds, then we will see our container running. See, Docker has successfully built the image and the image has been deployed in this particular URL. So we can go to that URL and see HTTP, the server name is 192.168.0.104 and the port is 8180, right? Here we can see a hello world, that means Docker has been deployed successfully, and if we look at that sample.txt, we get the sample text of that application. Okay, you can see dummy test line number 3 and stuff like that. So that means it is deployed successfully here. This particular piece of code was already there in the repository. That is what got built and showed us. If you can see the code for this Java, you see the developer might have put that particular code in sample.txt, which we see there were these 6 lines, so we can see these 6 lines in the application. Say the developer adds another line and we start the build phase again, then we see that line as well in the application. So that's how you automate the entire build process in Jenkins. If the build passes, then you see this kind of a blue button. If the build fails, you see a red button. That is how we go through the phases in our pipeline to build it, and DevOps really empowers you to do all these things in a hands-on mode. You can even see in the backend as well, if you have a fondness for the command line, you can see that it has actually deployed a Docker environment with the DevOps pipeline demo. This is where the server is actually running in 8180 port, which we can see. Okay, so that's how DevOps empowers you to run and automate an entire software development life cycle. So you're always welcome to use these tools in your day-to-day production practice and make your software delivery seamless and empowered and error-free. All right, so good luck with your classes. Have a great day. Thank you.